Hello and welcome to Physics Safari. My name is Abhishek and today I'm going to discuss with you the basic mathematics. Now this becomes more crucial for those who has opted for PCM because they will not be studying maths in deep detail. So I'm going to keep it basics as per the demand of physics. So I have segregated this in 4 parts: trigonometry, the calculus, maybe a little bit of graphical interpretation and the binomial expansion. Well, I think that should be sufficient. Okay. Now, let's start with the trigonometry. Trigonometry has been derived from the Sanskrit word which means trigonometry. So it deals with the relation of the sides and the angles of a triangle. All good? Now, the 3 basic fundamental trigonometrical identities that we have are sine theta, cos theta and the tan theta. Well, the tan theta could be written as sine theta upon the cos theta. So if I look in deep detail, these two is going to be sufficient because everything else has been derived from these 2 trigonometrical identities only. Now, how to know what is the value of sine theta, cos theta with respect to a triangle? So for that, let's have a triangle. Let's have a triangle over here and probably I would just name like A, B and C. Maybe right angled at B. All good? I assume this as theta in the angle in my consideration. Well, you could choose this also as a theta. It completely depends upon you. Excuse me. If I have taken this as theta, then the sine theta is defined as opposite upon the hypotenuse. I'm sure you guys are aware of it. Just to recap, the cos theta should be given as adjacent over the hypotenuse. Now for this angle theta, the opposite is going to be this side and the hypotenuse always is going to be this side. For this particular angle theta, the adjacent is going to be this one and the hypotenuse again is going to be this one. If I choose this angle as theta, then the opposite is going to be AB and the hypotenuse of course is going to be AC and the adjacent is going to be your BC. So sine theta over here is opposite. Let's suppose for this particular angle that should be BC upon AC. Likewise for the cos theta, adjacent which is AB upon AC. Now the tan theta is defined as opposite by adjacent. That means for this theta, opposite is going to be BC and the adjacent is going to be your AB. Now to cut short the time, I've already written the some values for the sine, cos and tan for given angles like 0, 30, 45, 60 and 90 because these are majorly used, right? So these are the value that already I've noted down. So you can pause the video and you can note down these data. Well, that's crucial, isn't it? Now, going forward, once you have noted down, let's move ahead and understand what we can do more with these trigonometrical identities, how to deal with these and what kind of questions that would come in physics. Okay, before I go ahead, degree is one of the measuring sort of units for the angles. We have one more that is called radian. So let's quickly understand a little bit thing about the radians. So if I say radian is another way to measure the angle. Now let us first define the meaning of radian, how the radian is defined. Well, if I look at a circle, and here we have the center. If I consider an arc, let's suppose this is A, this is B, all good, making some angle at the center. Let me denote the angle as O. This AB, the arc length AB, we write as AB with a cap. This is called arc AB. If this arc becomes equal to the radius of circle, if this becomes equal to radius of circle, let's suppose radius being R and R over here, then whatever angle is subtended at the center, that is going to be 1 radian. So this angle, if this arc AB is equal to the length of the radius of the circle, then this is going to be your 1 radian. Now the next stuff is how to relate the radians and the degrees. Guys, let me just tell you one thing. If I make the, if I take the entire circle, then the arc length is going to be how much? 2 pi r. So the 2 pi r subtends how much angle at the center? 360 degree. That subtends 360 degrees. What I'm interested to find the angle subtended by the arc with a length of 1 radius. So 1 radius, that would subtend how much angle at the center? 360 degree upon 2 pi, that would just give you 180 upon pi degree. Well, that gives you a relation of the radians and the degree. So 1 radian is equals to 180 upon pi radian. Likewise, if I want to find 1 degree in terms of radians, 1 degree should be given as pi upon 180 degrees. Now with this relation, I can actually convert this degrees to the radians. So 0 degree, of course, the 0 radians, no worries about that. Now 30 degrees, 30 degree, if I use this thing, I would be getting how much? Let me just use this space, pi upon 180 times for 30 degree. So that should be how much? Pi upon 6. Well, this is in terms of radian. This is in terms of radian. So 30 degree could be given as pi upon 6 radian, and likewise 45 degree is going to be pi upon 4 radians, and this should be pi upon 3, and this is going to be pi upon 2 radians. All good? Now the next thing that we need to understand is the concept of quadrants and the variations of angles, the values with the quadrant. Okay, so here is the duster. Let me just talk about the quadrants. So basically the entire, I would say circular track has been divided in 4 quadrants. Entire thing is divided in 4 quadrants. So let's have this quadrant over here. So maybe I could just draw like this. This is your first quadrant. This is your second quadrant. This is going to be your third quadrant, and this is going to be your fourth. Maybe I can use this Roman scripture. So third quadrant and the fourth quadrant. Now, how does it important to you? How is it important to you? Let me just say that this is your 0 over here. This is 90 degree. So we can write pi by 2 in terms of radians. This is going to be 180 degrees. So that will be pi radians. This is going to be 270, so 3 pi by 2 radians. One thing that is important to you people is to understand that in the first quadrant, everything means sine, cos and tan. They all are positive. So we write all positive. Here we have sine positive. Here we get tan a positive value, and here we get positive value for the cos. So all sine, tan, cos, we can memorize the way you want to memorize it. Now how it is important to you? Well, there are going to be situations in physics where you have to convert over the angles. Now let me just help you to understand the conversions, and then we're going to move into some important formulae. Okay, before I get into the conversion, I'm going to share with you a couple of formulae which is relevant to that. So for that, let's say sine of a plus b. You must know that. That is maybe formula number 1. Sine of a plus b. That is given as sine of a cos of b plus cos of a times of sine of b. And if we have a minus over here, let's say if you have a minus over here, I'm going to replace that also with a minus sign. No big difference, all good. Now the second one is cos. Cos of a plus b. Well, this is slightly different. This is going to be your cos of a times cos of b. If it is a plus, I'm going to have a negative over here. It's going to be sine of a times sine of b. And if you, let's say, have a minus over here, you're going to have a plus over here. All cool? So just remember these two standard formulae. Now going forward, the entire conversion is sort of segregated on 2 parts, plus minus 90 and plus minus 180 degrees. So let me first tell you of the conversion on the pi by 2, conversion on pi by 2, on pi by 2. Let's see how it all happens. Now the first thing, sine of pi by 2 minus theta. Now let me define theta for you. Well, theta is an acute angle. Let me say that theta is an acute angle. Theta is acute angle, so theta has to be in between pi by 2 and more than 0. That means theta is going to fall somewhere between 0 to pi by 2. It's an acute angle. Now acute angles are those angles which are less than 90 degree are called acute. Obtuse are those which are more than 90 but less than 180 are called obtuse angle. Now when we have sine of pi by 2 minus theta, and if you apply these formulae, you will be getting this as sort of cos of theta. And if I put cos of pi by 2 minus theta, and you're going to use this formula, you will be able to get how much? Sine of theta. And then if you apply for the tan pi by 2 minus theta, you again is going to get how much? Cot of theta. So sine became cos, cos became sine, and the tan became the cot. Fair and good. Now the next thing is going to be over pi by 2 plus theta. Okay. So the next thing that we need to understand is sine of pi by 2 plus theta, cos of pi by 2 plus theta, and then we have tan of pi by 2 plus theta. Now the sine pi by 2 plus theta, of course, let me first write, it's going to be cos theta. Let's say it's sine theta, and this is tan theta. Now we need to understand what's going to be the sine. These are the mother identities for me. Sine pi by 2 plus theta means this angle is falling in the second quadrant. It is falling in the second quadrant because 90 plus an acute angle would fall somewhere in between these, but in the second quadrant. In second quadrant, sine is positive, so this is going to be positive. Meanwhile, cos in the second quadrant is going to be negative. You must put a sign of negative over here. And the same goes along with the tan. Tan in the second quadrant is negative, so that is also going to be negative. So just understand that based on the mother identities, whether it is positive or negative in that quadrant, you have to pick the sign. All good? Now, so this was a conversion over pi by 2. We can also have the conversion over pi. Same two things would apply. Pi minus and pi plus. Pi is this one. Minus means I'm going to get it in the second quadrant. Pi plus will take me to the third quadrant. And you know that in third quadrant, tan is positive, which means sine and cos both are negative. All good? So let's have the conversion. So sine of pi minus theta, and likewise we'll have cos of pi minus theta, and then we have tan of pi minus theta. So first I'm going to discuss on the pi minus theta. Now the minus theta is going to pick it up in the second quadrant, right? And in the second quadrant, sine is positive, so that will remain as sine theta. Now if you get any sort of doubt over here, you can use these two formulae and things will be taken care of. Alright? If you sort of forget these things, just try it once on your own and I'm sure you will be able to memorize that. Now sine will remain sine, cos would remain cos, and the tan would remain tan. When we do the conversion over the pi, the identities remain same. You can just remember this in this shortcut ways. So the cos is going to be cos itself, no issues with that, and tan would remain just tan. Now the matter is we need to figure out the sign, whether it's going to be positive or it's going to be negative. Now the sign in the second quadrant, because pi minus theta is going to fall in the second quadrant, well that is going to be positive itself. So this is going to be positive, no issue with that. Coming to cos, cos has to be negative and the tan also has to be negative. All good? Right. Now let's move on towards pi plus. So here we have sine of pi plus theta, cos of pi plus theta, and then we have tan of pi plus theta. I'm sure you guys would agree that pi plus any acute angle would take you in this third quadrant. And in third quadrant, sine is negative, so I'm going to have minus sine theta. Even the cos is negative, so we're going to have minus cos theta, but this fellow tan is positive, I'm going to have positive tan theta. I believe you guys have understood this. Pause the video and note it down in one single page. These all 4 conversions should be in one single page. All good? Now, let's go ahead and see more about this. A quick 5 minutes I would take to sort of give you some very important formulae, and I'm sure you guys would note them down properly. Alright then, okay. Now, so few standard formulae that you should be aware of. Okay, this laptop is getting shut on. Alright then. Now, the first thing first, the relation of sine and cos. So sine square theta plus cos square theta would be 1. All clear? Now let us see what next can give me 1. The sec square theta minus tan square theta is also going to give me 1. Now you might be wondering, what is sec theta? To help you on that, let me tell you, 1 upon sine theta is termed as cosec theta, 1 upon cos theta is termed as sec theta, 1 upon tan theta is termed as cot of theta. So these three are the reciprocals of the sine, cos and tan respectively. So sec square theta minus tan square theta is 1. One more thing we have, one more, that is cosec square theta minus cot square theta is going to be 1. So these are the relation that gives you 1. Now just remember these when I'm going to discuss with you the differentiation and the integrations. Okay. Now the second set of formulae, which two are very close to me, as in they're going to be very helpful, I'm telling you. In a lot of situations they are going to be your helpful. So the first one, 1 plus cos of 2 theta, that would be 2 cos square theta, and number 2 is going to be 1 minus cos 2 theta, that is going to be 2 sine square theta. Guys, just make a note, these are hashtag important. Trust me, these are going to be a great help to you when you are in trouble. So please, okay, now I would just add a couple of more points over here. So let's say with respect to this one, if I say I have given as 1 plus cos theta, now what to do? If it is 2 theta, we get theta. So if it is theta, I must get theta upon 2. So 2 cos square theta upon 2, and the same will go along with this 1 minus cos 2 theta. And if it is 4 theta, I would be getting 2 cos square 2 theta. Important, okay? Now, the next few formulae that you should know is like probably I would say maybe a next set. Okay, so here we have, I want to represent the sine, cos and probably tan in terms of tan. Okay, let me write it here. So sine of 2 theta could be written as 2 tan of theta upon 1 plus tan square theta. All good? Now when we have cos of 2 theta, that is given as 1 minus tan square theta upon 1 plus tan square theta. And likewise, if I have tan of 2 theta, that should be 2 tan theta upon, if you just put 1 upon this, you will be getting 1 minus tan square theta. Just make a note, and this is going to be important. The reason being, in a lot of situations you have to convert the sine to cos and cos to tan, and tan of course you have to put it in single degrees. This is called multiple degree. You have to get it into the single degree, unit degree. Okay, one more thing I want to add over here. Let me just erase this part. Meanwhile, you guys can just make a note of this one. You should also know, I have told you about the sine a plus b, cos a plus b and minus 1 of course. That way you should also know about the tan a plus b and minus a, So here we have, you should know tan of a plus b, that is given as tan of a plus tan of b upon 1 minus, okay, 1 minus, alright then, tan a into tan b. If it is a positive, it is going to be a negative over here. Just keep that in mind. It's going to be negative over here. Likewise, if we have tan of a minus b, that is going to be tan of a minus tan of b. In the numerator, the sign would be followed. If it is minus, it's going to be minus. But in denominator, it behaves slightly different. It's going to be 1 plus tan times of a, tan times of b. All good? Well, these are the fundamentals of trigonometry, and I'm sure you guys have learned it over here. There are a lot to discuss in trigonometry, but we're going to discuss them whenever it is required in our physics classes. Okay, having done this, the next part that I'm going to cover up is the binomial expansion. Okay, so let's see you guys in the next video. Thanks for watching. Take care.